What's up, everybody? I am not a software engineer, but today we're going to take another look at slot machines, this time using the Pygame library within Python. And so what that's going to allow us to do is kind of move on from the text-based slot machine to a much more interesting graphical slot machine with music and animations and images and stuff like that. And I'm actually going to release the entire thing on Github. So we're going to walk through that basically from start to finish, starting with the system design element of creating a slot machine, all the way up until, when you can basically just run a main.py file and that will actually load and run the slot machine. So yeah, let's go ahead and get into it. So before we jump into the code, I just kind of wanted to talk about, what actually makes a slot machine a slot machine. And so I have this image here, and it's not an image that we're going to use in this particular implementation. But what you can kind of see is that there is this handle, and basically when a player pulls the handle, then these three reels that you can see that are just transparent right now basically spin downward, or it doesn't really matter which direction, but they spin. And then at a certain / pseudo-random number of spins, they will stop, and that will basically determine whether or not a player has won, right? And those symbols, they can be like, pretty common ones are like a banana or a lemon or the bar symbol or a 7 or something like that. And so in this version, if you get 3 of them in a row, you win some type of payout. Instead of doing 3 reels, I'm actually going to do 5 because it's a little bit more interesting. And that allows us to do more than just require like 3 in a row for a jackpot. So let's say we get 3 in a row right here. Then we could do some multiple of our player's bet. Or if there's 4 in a row right here, that would be maybe a slightly higher payout, etc. So that's actually the way that this slot machine is going to be designed, and I think it makes for a little bit more entertaining game. And before I start actually creating the various files, I just kind of wanted to show you what my folder structure looks like. And I've already done this project. I'm not just going to do it from complete scratch. I think that would be pretty difficult to do. But I am going to be using my previous kind of creation of this slot machine as a reference. Maybe things will end up a little bit differently, I'm not sure. But what I wanted to kind of drive home is the folder structure here. And basically what you see is I have a bunch of different .py files, and those will basically be kind of the way that I'm organizing this. And when I actually turn off the camera and start coding, what I'm going to do is kind of walk through the creation of each of these files and discuss what they contain, and then we can actually go ahead and add the logic within each of those files. And then I wanted to talk about the graphics and audio really quickly. So you can see there's a graphics and audio folder. Those are actually going to be where I store, what files you would assume, graphics will be the symbols and the actual background and things of that nature. I actually got a license for some interesting icons or really nice icons that you would see in like a slot machine on stake.com or something like that. And unfortunately, I can't share those on the GitHub repository, but I can share these kind of, they're not that great because I made them, but I can share basically these placeholder symbols. And if you wanted to go get your own artist to create ones that look better, then that would be super easy. I'll talk about the dimensions and stuff like that as we progress, but basically as long as you get the same dimension symbols, it's super trivial to just switch, which symbols are in the slot machine. And the number of symbols that you have actually determines the probability of, actually hitting a jackpot, but we'll talk about more of that later. And speaking of the actual audio, I can release the music, but I cannot release the sound effects. I actually use I just Googled like free sound effects or something like that, and just looked for some spin type effects and then modified them with Reaper a little bit. But I actually can and will release the song that is used in this slot machine. Because a friend of mine made it and he was cool with me actually adding that to the GitHub repo. All right, so I'm actually logged into my GitHub, and the first thing that I'm going to do is create a new repository. I do have this already saved in a private repo that I was just using for myself, but I just kind of wanted to walk through this since I'm going to release this publicly. And I'm just going to create basically a new repo, and I'm just going to call that Pygame slots for lack of a better word. And then I'm basically just going to say slot machine, let's see, basic slot machine using Pygame. And yeah, we're going to make that public. I will add a README file, and I think we can just use probably the Python git ignore, and I will create the repo. And now on my local machine, I'm actually going to clone this repo. And now I'm in that directory, so I should be able to just launch VS Code. So now I've just made a quick modification to make sure that I can do a git commit. And then I'll just make sure that that shows up. Cool, so we see the modification. And basically that means that we're ready to start adding our different files within this directory. Okay, so now that we have this directory here, I'm actually going to copy the audio and the graphics in, just so I don't have to redo that whole process. And again, we're going to be using that folder structure and those file names basically the entire time that I am going through this. So a simple copy and paste will be the easiest approach here. So unfortunately, as mentioned, I can't distribute the graphics and audio that was released by, basically other people, or that I have licensed myself on Adobe Stock. So I'm going to add those to the git ignore really quick. And now everything is looking pretty good. So what I wanted to do is just briefly talk about why I decided to make the different Python files within this directory that I did, right? So there are a couple things, and I wanted to really talk about what a slot machine is. So I'm going to go ahead and just kind of bring that back up. And I'm going to do that in a really bad MS Paint drawing, so bear with me for not having any better means of doing this. But when you have a slot machine, basically, a new age one, we're going to have a screen, right? So that's basically what the player sees. And so each one of these reels that, again, I'm going to do 5, but for demonstrative purposes, I'm just going to have 3. Each one of these reels will basically spin downward and then show a symbol here. And so in order to mimic that, we basically need to have this concept of the machine itself, but then we need to have the concept of the actual reel itself. Right, and then finally we need to have the concept of the symbol itself. So here's kind of this machine, which is this overarching thing right here. And so we're going to actually have a class for the machine. And so that is going to encompass basically everything. And then we're going to have this red section here is going to be a set of 3 different reels. Right, and then finally we're going to have this subset, which is going to be symbols. And so what we'll start to see, right, is this would basically be a win because it's 3 of the same symbol. But what we'll have above and below are other symbols. And so each of those are going to be a sprite. And if you're familiar with Pygame, you'll probably see where I'm going with this. Whereas the reel itself will contain a sprite group, which stores all of the sprites or symbols. And so this is going to give us kind of a pretty nice way of keeping track of what all of these things look like within our directory structure. So what I'm going to start off with here is the main.py file. And this is kind of going to be a generic looking I want to say just kind of like a Pygame file where you would expect to see your game loop, right? So I'm not getting into like the very basics of game programming in this. I definitely have a couple of videos that I have referenced to kind of get to this point, and I have linked those in the description of the video if you would like to get up to speed. But basically what I'm going to do here is begin with my game class. And so I'm going to do something like class game. Then I'm going to create my init method, which of course takes self. And I'm going to comment that this is going to be my general setup. And if you're familiar with ClearCode, he's definitely a fantastic resource, and you might notice that I kind of set up stuff similar to him. Definitely give credit to him for some of my design choices. In any case, what I'm going to do is go ahead and begin with my pygame.init. And this is all kind of boilerplate Pygame code, by the way. So you'll notice that I'm getting basically some type of error here, and that's because I haven't actually imported Pygame yet. So yeah, of course, I am working under the assumption that you have Pygame installed via the pip package manager. But once we have that, then we can go ahead and create our screen variable, which will just be self.screen, and that of course is pygame.display.set_mode. And I'm going to have just a width and height variable that I call from another file that I have to create here, and I'm going to create that now and call it settings.py. So of course we need access to that from within this file, and so I can do something like a from settings import asterisk. And I don't actually have anything in this file yet. And I'm going to copy and paste our display settings in, just because it's a bit easier. And so for now, that's what settings.py will look like. And basically, we're pulling from this height and width variable here, which, as you can see, is going to be 1600 by 1000. And we'll talk about why I made those choices here in a bit. But for now, we know that this can access those variables from within settings.py. So back in main, I'm going to go ahead and give this Pygame window a name. And the name will be set with pygame.display.setCaption. And we're just going to call it slot machine demo. Cool. And so what we're going to do is set the clock to the pygame.time.clock function, right? And I'm not going to get into the nitty-gritty on what that is, but there is great documentation for that on the Pygame page, right? So I would definitely recommend taking a look at this. We're going to be using a concept called delta time, and there are way more references on what delta time is. I'm not even going to get into it, but long story short, I'm trying to make this not actually care what the frame rate is in order to have a similar experience across different types of hardware. So with that being said, we can go ahead and just do a self.clock equals pygame.time.clock. And so what I'd like to do now is set the background image, which also is going to be defined in settings.py. I have yet to copy that variable name over, but basically that's just going to be self.bg_image pygame.image.load, and then I'm going to have a variable called bg_image_path, and I'm going to put that in settings. And I'll do that in a second here. And then I'm basically going to I'm going to create a new instance of my machine class, which I haven't created yet, but I'm going to do that here, and I'm going to make a note of it. I'm going to say to do create machine class, and basically, yeah, that's just going to be self.machine equals machine, and I'm going to have to import that. And I'm going to do a from machine import machine. And so now is as good of a time as ever to actually create machine.py. And I will have a file called machine, or a class rather called machine, with my def init self. And for now, I will just pass. So this doesn't actually do anything, but it does have access to it, and it can instantiate it. It just literally does nothing. So yeah, I'm going to create a new variable called self.delta_time, and I did have some help kind of understanding delta time from a good friend of mine, so thanks for that. Again, I'm not going to go into it a whole lot. I'm just working under the assumption that we are basically implementing everything in an FPS or frames per second agnostic manner. And I'm going to go ahead and set this to 0 for now. It will be referenced multiple times throughout our animations and stuff like that, which again helps us break away from kind of frame limits depending on which hardware you're running this on. So I'm going to create kind of a section here just called sound, and I'm going to use that song that I basically mentioned. That's just going to be main_sound equals pygame.mixer.sound. We're going to go to the audio subdirectory and then track.mp3. And then we're going to specify basically an infinite loop, right? So when this track is done playing, it will just play again. And you do that with the loops equals -1 parameter. Cool, so now we need an actual run function. So I'm going to define that by doing a def run, and then self will be the only parameter there. And I can have a self.start time, and this will basically tell us when the game starts. And we're going to do that. We're going to call pygame.time.getTicks at the very beginning when this run method gets called. And so yeah, so now I can start my game loop, which is basically just while true. And then we're going to handle the quit operation. And again, you know, this is kind of boilerplate Pygame stuff, so you've probably seen something similar before. But I'm just going to do handle quit operation as a comment, and for event in pygame.event.get, if event.type equals pygame.quit, pygame.quit, and we'll also sys.exit for good measure, but that means we need to import sys. All right, so that handles the quit. And so now we're going to basically go back to our time variables I was mentioning, which again will be self.delta time. And we're also going to have a self.start time. And these are going to run every time the game ticks, which, you know, that without going into too much detail, that's basically every time this while statement is true, then these things will happen, right? We're basically looking for a quit action. We're also setting delta time to basically what I'm going to put here, which is going to be pygame.time.get_ticks minus self.start_time divided by 1000. And then I'm also going to basically say pygame.time.getTicks is just going to be my start time. And I think I can actually remove this since I call it over and over again. But yeah. So at this point in time, we have our time variables, and what I'd like to do is a pygame.display.update. And basically this will just update the display every tick. So that is something that we do want. And then I can basically draw our background image, which has been imported as self.bg image. So in order to do that, I would use screen.blit, right? So our screen variable is called screen, and blit is how we draw onto that image. So I'm going to do a self.screen.blit, and then we're using our background image, which is this right here. And we're going to do that at the coordinates of 0, 0. And then let's see, we also want to update the machine constantly. So we're going to feed our delta time variable into the machine, the instance of the machine class, which again is self.machine. So the way to do that is self.machine.update self.delta time. And then finally, we're going to have our tick rate, or our FPS rate, be self.clock.tick, and then our variable is going to be called FPS. And that FPS will be in the settings file. And lastly, we'll have our if name equals main. And then we're going to basically create a new instance of our game class. And then we're going to continuously game.run. So this will run over and over again, and everything in here will basically function constantly. And I've noticed that this actually needs to be within the while true indentation. So I'm just going to move that over. And this should work once I set my BG image path. And then I think I need to set FPS as well. No, I already have FPS as 120. But I do need to set BG image path. And let's see. I will create a new section for that. I'm just going to call that images. And I will have my BG image path equal to graphics neon bg.png. Cool. So now we should be able to run this with a little bit of luck. And what I'm going to do is bring up the directory Pygame slots. And if you do a Control Shift and then right click, you can actually get a open PowerShell window here, which is pretty nice. And I can basically just python main.py. And so we have game object has no attribute start time. And so I actually do need to have this at the very beginning of this function. And we'll give that another try. And machine, of course, doesn't have an update method yet. So I will just set that to pass. And I'll add the delta time as a parameter. And we'll give that a try. And it works. So basically what we have is a very loud soundtrack. And since it's going to take quite some time for us to get to the point where we're actually ready to, spin the slot machine and play the slot machine, I'm going to comment out the sound because having that play every single time might be a little bit annoying. So we'll come back to this and re-enable it later. But as you can see, we're basically at the point where we have our Pygame window opening. It is the proper height and width, which is 1600 by 1000. I'm going to launch that one more time. And I'm just going to show you basically where we're going next, right? So there aren't actually grid lines here. But I am going to, and I actually I can change that. If we wanted to, I'll show you how simple it is to swap out the image here. And this is the one that's going to actually be in the GitHub repo. So if I go to graphics 0, I think that's what it's called. Let's see, graphics 0, and then bg.png, yeah. This will actually load with grid lines, and so you can see here that we have basically 5 columns. 1, 2, 3, 4, 5. And so those will be our reels. And kind of the next step here is to draw 3 symbols in each of these reels. But before we do that, I kind of wanted to touch on the fact that we are going to be spinning these, right? So we have to think about what happens when this symbol moves down, right? We need to basically have another symbol that spins downward into this to take its place, or it's not going to look natural. So what I'm going to do is I'm going to have 5 reels, and I'm going to create a class called reel. And in those are basically going to be 5 sprites. And I'm going to have one above, up here, and I'm going to have one below. And basically, we're going to see why that is. But once I have my bottom invisible sprite past a certain point, I'm just going to get rid of it. And then I'm basically going to create another one back at the top above this invisible one. And so it's kind of going to be like a stack, if you're familiar with the stack data structure. And that's basically what's going to give us the spinning effect. But more on that later. And really quickly, what I'm going to do is just ls and see all of the new files within here. And I'm just going to do another git add -a, git commit -m, and I'm going to put created main machine and settings files. Cool. I also did some other stuff, but I think that's a good enough summary. So then I can do a git push. And I'll go back over to the directory. And we can see the new stuff here, which is nice. So I'm going to be doing this pretty often. I'm not going to create new branches and stuff like that, even though I did when I was creating this. But it's going to take me a while to record this video specifically. But every time I reach a milestone, I'm just going to commit all of the files to the Pygame slots repo. And then resume when I have the time. So I had a change of heart, so to speak, when thinking about how I was going to do this with the different symbols. And I mentioned that I did license some higher quality symbols out using Adobe stock, but I'm just going to use my less than stellar images that I created myself, just to kind of avoid any confusion. And then at the end of the tutorial, I'll actually demonstrate how easy it is to switch to some higher quality symbols. But for now, we're just going to use the 0 directory and then the symbols within this directory here. And so really quickly, I wanted to just bring up the settings.py file because I can actually basically import those by way of a dictionary. They're not actually going to be imported in terms of Pygame just yet, but we're going to reference the dictionary that I'm going to create in order to do that. So what I'm going to do is create basically just a new comment here, and I'm just going to say 5 symbols, which is, at this point, it's fairly unlikely to get a win, but it happens enough. But in any case, I'm just going to say 5 symbols for testing, or rather 5 symbols for demo. And then basically that's just going to be a dictionary, right? And I'm going to create that as the name symbols because we're going to be referencing this quite a bit. And basically what I want to do is have a friendly name as the key and then the actual path as the value. So we're going to go ahead and go back up to images and create something called sim path. And that's just going to be kind of the beginning of the path, so I don't have to copy and paste the same thing over and over again. And that's going to be graphics 0 symbols. So yeah, this is the graphics /0 /symbols directory. Now back in the symbols dictionary, I'm going to basically just refer to what these are. One is a diamond, one's a floppy disk, one's an hourglass 7, and telephone. So that's going to be the names of my keys, right? And I'm just going to go in alphabetical order, starting from the diamond, and that will just look like diamond. And I'm going to go through and do that. All right, so now we need to actually create an F string, which will then reference the sim path variable, and then it will have the full actual file name, which in this case is 0_diamond.png. All right, so now I have my symbols dictionary, which basically has the friendly name for all the symbols, and then it has the actual file paths, and this will be referenced multiple times, especially when we're creating our reel and thus our actual symbols, which are part of the reel. So right here in the settings.py file, in this actual symbols dictionary, is where we can incredibly easily switch the images, right? So you can just imagine if I change this sim path variable here, or I just change these file names or whatever, then it would be really easy to just kind of swap out the images. Now the one thing that I will say is worth noting is that these images are all .png images with a transparent background, and they're all a size of 300 by 300 pixels. And so that fits perfectly with our 1600 by 1000 height. If you recall, there is this black bar at the bottom, and this is 100 pixels high and 1600 pixels wide. This is actually going to be our user interface, which we're going to keep track of our balance. We're going to keep track of whether or not we won anything from our previous spin, and then we're going to keep track of our bet size. So this is not actually part of the playing field, so to speak. But what we have right here, as I've mentioned, are our 5 columns or 5 reels, and that is where we're going to begin drawing our symbols. So within the settings file, there are a couple other things that I wanted to keep track of in images. I'm actually going to have a list that keeps track of the indices that I'll actually have on each one of my reels. And again, if we go back to this, we're basically going to have a 0 index, which is above, and then we're going to have 1, 2, and 3, and then we're going to have this 4 index. And that again are the two, that includes the 2 invisible, if you will, sprites that aren't going to be part of what we're looking at. So this is essentially index 1, 2, and 3. And so if there are symbols, we're basically going to use that to determine whether or not a player has won any money. So if they have 3 in a row on basically index 1 is what we'll call this row here, then that would be a win. So that's basically the reason I'm going to keep track of this. And it might not be the best approach for doing it, but it works in my case. So I'm going to go ahead and create this and call it game indices. And then we're just going to set that equal to 1, 2, 3. And I'll put a note there. It basically says 0 and 4 are outside of play area. And then what I wanted to do is actually have an offset for the... I wanted to have a couple of values here. One is going to be start x and start y. And those are going to be equal to 0 and negative 300 respectively. And so that's going to kind of give us, I'm going to keep loading this. I should probably just leave it open at this point. But basically what we're going to start at is a 0. So this point right here in the top left, of course, is 0, 0, right? And so when we're creating our first symbol, that actually is going to be at a point 0, negative 300. And we're going to use the top left as kind of the place where that image slash rectangle is located, right? So that's going to be outside of the play area, but that is going to be our starting point effectively, 0, negative 300. And if we open up a calculator, you'll also notice if I were to say 1600, which is our width, divided by 300, we actually have more space there than we have reals, right? So if we wanted to see how much space we actually need to take up per symbol to get a width of 1600 pixels, we can just do 1600 divided by 5 reals, and that is 320. So we're actually going to add an offset to our x value every time we create a new symbol. And that, or rather, every time we create a symbol on a reel that is further to the right. And so I'm going to create a y offset as well. That's just going to be equal to 0. And we will create x offset, y offset equals to 20 and 0. And we'll touch on that in a moment. So back in our machine class, we have a couple of functions that basically are doing nothing at this point. And I'm going to create another one. And I'm going to do that up a little bit closer to the top here. And that's going to be called spawn reels, with self as the only parameter. And basically what we're going to do is we're going to see if there are any reels in our variable called reel list. And we haven't actually created that variable yet, but that will be part of the initialization function. So I'm going to go back up here. And we're going to need to get the actual display surface. So I'm going to be doing a self.display underscore surface equals pygame.display.get underscore surface. And then what I want to do here is basically have this list, which is actually, it's going to be a dictionary. And the reason is because I'm going to have key and value pair for all of our reels, right? But that's going to look like self.reel underscore list equals, and we're just going to have that be a blank dictionary at first. So when we call this spawn reels function, when the machine gets created, we're going to actually check to see if we need to spawn our reels. And we're only going to do this once, right? Because once we have 5 reels, then we're good. We just need to worry about the symbols within each reel. So basically, we're going to check to see if self.reel underscore list has anything in it, which we, of course, can do with if not self.reel list. And then what I'm going to do is create a couple of coordinates, x top left and y top left. And we're going to have that be equal to 10 and negative 300. This 10 kind of goes back to that 20 offset, and we're going to have this on the left and right of each image. And basically what I'm going to do is have a while loop that says while self.reel underscore index is less than 5, right? Because we're going to be using 5 reels. I'm going to say if self.reel index is greater than 0, then I'm going to have the x top left and y top left equal to and this is where I'm going to be adding my offset. And this is going to happen on every time except for the first reel, right? Which will of course be at index 0. So we're handling reels 1, 2, 3, and 4, or rather the reels at index 1, 2, 3, and 4. And so I'm going to x top left plus 300 plus the x offset, which is basically going to change the x value of where I place my image. And then the y coordinate will just be y underscore top left. And of course I need x offset available here, so I will have to, from settings, import star. And so if this is not the case, then we'll just move on to the next kind of portion of this function, which is just going to be self.real_list self.real_index equals real, which will be blank for now, but I'm just going to have coordinates there, x top left and y top left. And we need to create real class. And finally, we will basically just iterate our self.real_index variable, and we need to keep track of this up here. So when I create a new machine, I'm going to have a variable that keeps track of which index, or rather which real index we are currently at, and I'm going to start that with 0. Self.real_index equals 0. So just to go over this, once the spawn real function is called, we're going to check to see if this is blank, which it is. Then I'm going to set some coordinates, and then I'm going to basically do this while there are less than 5 reals. And yeah, at the end of the day, I'm basically just creating a new key within the realist dictionary, and that's going to be, the key is going to have the value of whatever the index is, and then within that I'm going to instantiate a basically just a real object. And so of course I need to create the real class. Okay, so the real class itself, I'm going to go ahead and store in a new file, and I'm just going to call that real.py. And then I'm going to need access to my settings, so I'm going to do from the settings import asterisk. And I also need to import Pygame and random, and we'll get into why I'm using random here in a bit. But the first thing I'm going to do is actually create my class, and of course my def init. I should just have a shortcut for this. There probably is one, but within that, as a parameter, I'm going to take a position, which you can see right here, right? So that x top left, y top left actually is a tuple that will pass in as the parameter there. In any case, we're going to do a couple things in our init function, and similar to how I have a real list, we're actually going to keep track of our symbols in a variable called symbol list. Now, instead of that being a dictionary the way that it is here, it's going to actually be something, and if you've done any tutorials with Pygame before, you're probably familiar with this, but it's going to be a sprite group. So I'm going to create self symbol list pygame.sprite.group. And of course, going back to the documentation, there's quite a bit of stuff here if you would like a bit more in-depth explanation on what that is, but it basically will allow us to organize our sprites a little bit easier. So another thing that I want to do is I actually want to take the keys from my symbols, and I just kind of want to like shuffle them, right? That basically means I don't want to create 5 reels that basically load these images in the same order, because then they're going to look identical. And you know, on a traditional slot machine where the symbols are fixed or whatever, that might be preferred, but in our case I don't want to do that. So I'm going to create a shuffled list, and what I can do is actually do a self.shuffled keys equals list symbols.keys. So that's going to go through my settings symbols here, and it's just going to look at the keys, which of course are diamond, floppy, hourglass, 7, and telephone, and it's just going to shuffle that, which is part of the random library. So I can go ahead and do a random.shuffle self.shuffled keys. And that will modify my list in place, and then I can basically say, and the reason that I'm going to do this next thing is if I had more than 5 symbols, and so it's kind of unnecessary since I only have 5 symbols, but in any case, it's self.shuffled keys equals self.shuffled keys until index 5. And I'm just going to put a note here that says only matters when there are more than 5 symbols. But yeah. So you might be wondering, okay, you know, if I have like 10 symbols or something like that, then my reels potentially will have differing symbols. So how could I have a match, if there were like symbols that were in one reel that aren't in another reel? That gets mitigated when we start adding random symbols once we kind of get to that stack data structure that I mentioned. And I also want to have a variable, which I'm not going to access until we start animating things, but I do want to have a variable that says reel is spinning, and I'm going to set that to false. And we'll talk about that one later. So I do have some sounds that I'm going to just kind of place in this section here. And again, I can't really add the sound effects since I got them from a free sound database, right? But just to kind of show you what that looks like, I am going to implement them. Okay, so in our init function, we basically need to go through our shuffled keys, right? And so again, this is going back to settings.py, and we're going to go through and iterate 5 times, right? Because there's going to be 5 keys. They're just going to be in different orders because of shuffle right here. What I'd like to do is get the index as well as the item in that list of shuffled keys, and I can do that with the enumerate function. So for idx item and enumerate self.shuffled keys. What I'd like to do is add a new symbol, which we don't have a class for symbol yet, but we will create one shortly. So I'm going to do a self.symbol underscore list dot add, and I'm then going to add a new instance of symbol, and then I'm going to do that and get the actual value at symbols index of item. And I'm going to pass in a couple parameters there. One is going to be the position. Of course, we need to know where to create or rather load the image and then actually, place it. And then we're also going to have an index. And that should do it for that. Of course, we don't have a symbol yet, so that's going to throw an error. Other than that, I'm going to get the position, and I'm going to have that be a list so I can actually get the index. This is going to be input as a tuple, and so here turning it into a list allows me to go to the pos index of 1, and this is going to be the y value because we get x and then y, and y of course is going to be at the 1 index, and I will just add 300 to that, and then I will turn that back into a tuple. So yeah, what I can do at this point is basically just get rid of the indentation all the way to the back and create a new class, and I'm going to call that symbol. And that actually is going to inherit from pygame.sprite.sprite. And if you've followed any of ClearCode's tutorials or any Pygame tutorials, this will look very familiar to you. And of course we can do our def init self, and this is we're going to have a couple different parameters here. We're going to have a path to a file, right? Because we need to know what the actual file is that we're going to load. So I'm just going to call that path to file. Then we're going to need a position, and then we're also going to need an index, and we'll basically be using those in the symbol class multiple times. But this should be def here, and we also need to do the super underscore init as part of standard practice when creating something that inherits from pygame.sprite.sprite. So the first thing that I want to do is get a friendly name of this path to file, because this is going to be like a full file path, and that's not going to be great to read constantly. So I'm just going to create a friendly name variable, and that's going to be self.symtype. And we're just going to chop up path to file using the split method available, or split function rather, available to string. And then we're going to take an index of 3. And so that's going to give us that, basically what we see here. So the 0 diamond.png. I'm going to get rid of the .png so I can do another split on the period, and then we'll just take the 0 index. So that will give me 0 diamond, which, you know, I could break this down even further and get rid of the 0 underscore, but I think this will probably be fine for now. So I want the position and the index to be available in the actual instance of the symbol itself. So I'm just going to do a self.pos equals pos and self.idx equals idx. And now what we're going to do is actually load the image. So this is pretty standard stuff. If you're used to pygame.sprite.sprite, we'll do a self.image equals pygame.image.load path to file. And then, of course, convert alpha. I was following along with a clear code tutorial, and he kept mentioning to do this, and I totally forgot to do it when I went off to make my own slot machine, and the performance is horrible. So yeah, definitely remember to add the .convert_alpha. And then, of course, for the rectangle, we'll do self.rect equals self.image.getRect, and then our top left will actually just be that position that we have available to us. And finally, we're going to keep track of an xval, and that'll just be self.rect.left. Cool. So at this point, I think we are able to draw our images. Now, what will happen is our machine has this function called spawn reals, and real is not currently available to machine. So if we go to our imports in machine, basically we need to add from real, and I like to do this in alphabetical order, from real import asterisk, and I will do that here. And then finally, I'm going to save this. And another thing that we need to focus on is what actually happens when the machine class is created. So we're calling self.machine.update every single tick in our game loop. So basically, right now, the only thing that happens when that gets called is pass. It kind of makes sense to add something to spawn our reals. So in order to call that once, rather than putting it in our update function, which again is currently doing nothing, we can just put that in our init function. So I can do self.spawn_reals. And that should create 5 reals starting with an index of 0, and place our images basically starting from up here, which is this invisible one, and then it's going to go downwards since we're iterating through, I think, up till 5, right? So we're adding to our real list with that this right here, and we're starting with 0, of course, and then getting up to this 0, 1, 2, 3, 4, and that should have all of our images the next time that we run this. And I have an issue over in real. That should actually be getRect. And I believe we actually do need to iterate through our real list within the machine. And we can basically do that by doing a for real in self.real_list. And then we'll do self real list at index real dot symbol list. And there's actually a draw function available to the Python Sprite Group. So I will do that on the self.display_surface. And then I will also do self.real_list at index real dot symbol list dot update. and make sure that I spell this correctly. And then I'm going to go over to that update function, which currently does not exist, but I will create that as def update self and just put pass for now. So now we can see that this does load. We have an interesting kind of bug where we see our invisible sprites that are loaded down here, and for whatever reason they're like bleeding into this kind of background. That is okay for now because we're actually going to draw over this in the UI. But basically, yeah, I mean, we have the ability to spawn these reels a single time when we create our machine class. I'm going to clear this just to kind of demonstrate that we are in fact, now remember there's a 7, a diamond, a 7. When I close this, we'll have a diamond, diamond, floppy. So yeah, this is actually going and creating random reels here. And it actually looks pretty decent. Again, these symbols aren't the best in the world, but you can tell that if you added some and you know, maybe a better background or something like that, this would actually look pretty good, you know, without doing a whole lot other than changing the images. Again, these are just placeholders, but it will allow us to get to a point where this thing is working and functioning like a slot machine. So at this point, I'm going to go through and I'm going to save everything. Yeah, I think the next step is going to be actually animating and having the ability to kind of press, for example, the space bar, and then having these move downwards. And of course, before I call it quits officially, I'm just going to git add a, git commit -m, and then added basic. All right, and then we can go ahead and git push, and there we go. So back in our reel.py file, I'm going to go ahead and create a basically just a new function, and that's going to be called animate. And this is going to actually be a fairly lengthy function, so I'm going to add a bunch of comments and stuff so we can kind of keep track of what's going on. But yeah, so def animate, and we're going to take self and delta time. And the reason that I'm going to be taking delta time as an input here is we're actually going to add a delay to when the reels spin, so it kind of gives it like a nice aesthetic feel, and we'll kind of talk about that as we progress. But basically what I'm going to do is check to see if my reel is spinning. And of course we have this boolean here which is set to false when we initialize a new reel. But basically I can look to see if self.reel is spinning. And at that point, I'm going to add a delay to when I start my animation. So that's just going to be self.delay _ time minus equals delay time times 1,000. Of course, 1,000 is milliseconds. Sorry, this should be delta time. And then I'm going to have a self.spin time minus equals delta _ time times 1,000 milliseconds. And I'm going to have a boolean here called reel is stopping, and that's going to be equal to false. So I actually did have a friend help me with the logic here, but what is going to happen is every single time this is called, we're basically just going to subtract a certain amount of time from my delay time and my spin time, and that will be used to determine whether or not I should be spinning or stopping. So we're going to do a check here, and that's going to be if self.spin time is less than 0, then we're technically going to be stopping, and so we're going to change that boolean reel is stopping to true. And then what I'm going to do is I'm also going to check if the delay time, so self.delay time, is less than or equal to 0. And then I'm going to actually animate in this place right here. So I'm going to make a note that basically says stagger reel spin start animation. And then I'm going to have another note here that basically just says iterate through all 5 symbols in reel, truncate, add new random symbol on top of stack. So this is basically where we're going to do a couple things. One is going to be look at all of our symbols and then move the rectangles down. And so that's actually going to be numerically, like it's actual addition, right? But what's going to be the result is that this is going to move down 100 pixels every time this is called. So in order to do that, I'm just going to for symbol in self.symbol underscore list symbol.rect.bottom plus equals 100. And so every time, you know, basically every tick, each of the symbols in my reel will move downward by 100 pixels. And so what I'd like to do is then check to basically see if there is a rectangle in the current symbol list. And if there is one that is below, that has a top rather, top Y value that is, again, numerically it's above, but I'm talking about underneath, and I'll give you a visual here. Basically, I'm going to look to see if there's one of these where the top is below this like 1200 mark. And if so, then I'm going to remove it, right? And so what that looks like, and I'm going to do this within the same for loop, is, and actually let me put a note here, correct spacing is dependent on the above addition eventually hitting 1200. So basically we're going to start with a number, and every time we add 100 to it, we basically will eventually hit 1200. And when we hit 1200, then we know to remove it. And I'm going to do that so long as reel is spinning. So if symbol.rect.top is equal to 1200, then I'm going to do another if statement. If reel is stopping, then I'm going to have a self.reel is spinning set to false. So the stop sound will play self.stop underscore sound dot play. And again, while in development, I've just commented this out so we don't have sounds playing constantly. So once we play the sound, then what I'm going to do is actually, we know that this has been set to false. We know that we played our sound. So what we also need to do is, once this hits 1200, no matter what I'd like to do is symbol idx equals symbol.idx, right? I'd like to get the current index, and then I'd like to symbol.kill, and then now I'll actually spawn a random symbol rather. So what I'm going to do is go to my symbol list, then I'm going to add a new symbol. I need to make sure that I'm pulling from shuffled keys. So let me add that here. And now what I'd like to do is just rerun this and ensure that there are no errors. That's always a good sign. Okay, so there's no errors. The only thing is this isn't actually being called at any point. So I'm going to tidy this up a bit. And then I'm going to go back over to my main.py. So we're not actually getting any input at all. The only thing that we have for events are basically, you know, when an exit happens, we actually quit the game, right? So if I go back over to machine, we basically need to have something that is constantly looking for input, right? And so that is going to end up being a new function. And since that is such a high priority function, I'm literally just going to put it basically at the very top, right below the init function. And I'm just going to call that input. And basically we're just going to get key input by calling pygame.key.get_pressed. And this is going to happen constantly. So I'm actually going to put self.input in my update function. So since this is called every single tick, I will basically be checking for input every single tick. So there's still a couple things that I need to add. And I'll put a quick note here. Checks for space key ability to toggle spin and balance to cover bet size. So we're actually going to check the user's balance before we allow them to spin, but we will implement that a bit later. In any case, if keys pygame.k space, again this is the space key, and self.can underscore toggle and self.cur_player.balance greater than or equal to self.cur_player.bet size. You'll notice there are a couple things that have not been defined yet. We'll get to that in a second, but then I'm going to do a self.toggle underscore spinning, which we'll actually put in our cooldowns here in a second, and then I'm going to have a self.spin underscore time equals pygame.time.get underscore ticks, and then I'm going to self.cur_player.place bet, and then I'm going to self.machine balance plus equals self.cur_player.bet underscore size, and finally self.cur_player.last underscore payout equals none. So I'm actually going to comment these out for a moment since we don't have a cur player and we're not actually keeping track of the machine balance just yet. What I would like to do is I kind of think that I should comment this out for now since I haven't implemented that stuff. And I'm just going to have my if statement be pretty simple, right? So my toggle spinning, basically what I'd like to do is I'd like to check if a certain amount of time has passed between the last time spacebar triggered a spin and when I'm allowed to do that again, right? I would like to implement a new function, and that's just going to be called cooldowns. And that one's also very important, so I'm going to put that above here. Def cooldowns. And basically the first one is I'm just going to iterate through my reel list, and if I have a reel that is spinning at all, then I'm going to set can toggle to false and spinning to true. And basically I can just do that with a quick for loop here, but I'm going to say only lets player spin if all reels are not spinning. And that's just going to be for reel and self.reel underscore list. If self.reel underscore list reel, index reel, dot reel is spinning, self.can underscore toggle is false, and self.spinning is true. And then what I would like to do is have something happen, you know, if can toggle is false, right? When I call this function, it needs to basically change whatever the current value of can toggle is, right? So what I'd like to do is check the negative case, or if not self can toggle, right? So if not self can toggle, then what I need to do is make sure that all of my reels are not spinning. Because I'm only going to allow this to be set back to true if I know for a fact that the slot machine is no longer spinning. So I'm going to paste this in because it's a bit lengthy, but basically I'm just looking to see the value of reel is spinning in my entire number of reels, right? So I'm basically making sure that the count of the false value for reel is spinning is equal to the total number of reels that I have, which is 5. So in that case, I can go ahead and self.can underscore toggle and set that to true. And that should be good for the time being. So I do need to actually have my toggle spinning function, and I'll put that down here. Def toggle spinning. And basically what I'm going to do is check to see if I can toggle, right? So if self.can toggle, self.spin time, this is just getting the current time when the spin takes place, pygame.time.get underscore ticks. And then I'm going to set spinning to the opposite of whatever it was. And then self.can underscore toggle will be set to false for the time being. So then what I need to do is iterate through my reel list and basically start spinning each reel. And so this is just going to be another for loop. For reel in self.reel underscore list. Self.reel underscore list at index reel dot start spin. So that's going to be a new function. It's going to be int, and that's going to be the reel that we're currently in. And then I'm going to multiply that by 200. So 200 milliseconds is going to be my delay for each reel. It'll give it this kind of like staggered look, which you'll see here in a moment. Then I'm going to have my self.spin underscore sound.play, which is going to be commented out for the time being. So we do actually need to go over to reel and take a look at this start spin function, which is not currently present. So start spin is just going to be right underneath animate. And I will just call that literally start underscore spin self, and it's going to take delay time as a parameter, which are the numbers that we actually had in our, I guess right here, right? The start spin. This is going to be the delay time. So yeah, so we have our self delay time. And then we're going to have self.delay time is equal to delay time. Self.spin time is going to be 1000 milliseconds plus our delay time. And then we're going to set reel is spinning to true. And so we're going to try and run this. Machine update missing one required positional argument delta time. So I didn't actually need update here, I needed input. So let's try that again. Alright, so I'm going to hit the space key. And so we get machine object has no attribute can toggle, which probably should go in the init function. I do not believe I have added that just yet. So I will go back up to the init function within machine, and I'll go ahead and just have a self.can toggle set to true. And let's try that again. Machine object has no attribute spinning, so I need to set that as well. Self.spinning, and we'll have that set to false since it's not spinning when the game starts. Okay, so this did not do anything when I hit space. Basically, we need a draw reels function, which I have not created just yet. And I'm going to go ahead and do that now. Self.draw underscore reels delta time. And so this will allow us to get our actual animation with the delay and all the stuff that we just added. And I will go ahead and basically put this, let's see, cooldowns. This should not have an S. I guess spawn reels only happens once, right? So it can kind of be towards the bottom, but I will have a def draw reels self and delta time. And basically this is just going to be for reel in self.reel list, and we're going to call the animate function on the reel. So self.reel underscore list reel dot animate delta time. Okay, so now other than this just being drawn, we should see the animation actually occur since we call animate. We were not calling it before. Okay, so that was a bit further than we've been getting. List object has no attribute keys. So this probably happens after I truncate the bottom symbol, right? So if we go back over to reel and we look here, shuffled keys is already a list, and it doesn't need keys. I think I can just get rid of this. If I'm not mistaken, but in that case I should get rid of this. Let's try that again. And there we go. That is essentially the animation that we would expect. Now, if you can hear this, I'm not actually able to spin it a second time, but that looks pretty good. So let's go ahead and relaunch it. And yeah, that's basically it. That's the animation for the slot machine, and it looks really good. So again, I had a little help coming up with the staggered animation, so definitely thankful for that. But by and large, you know, this thing looks really nice as is. And now that we've hit a pretty significant milestone, I will of course git add a, git commit -m, added spinning animation, and I will push that to the repo. Okay, so I need to check my, I guess the can toggle cooldown, right? Because I think that it's not actually, I don't think that this is actually going back to true. So let me go ahead and put a print statement here. And then I will rerun this and see what happens. I don't think this ever actually is true. And the reason is because I don't have cooldowns in my update. So we need to constantly check cooldowns, and I will do that by putting cooldowns here. And I will then rerun this. Alright, so that printed false. Okay, whatever. The print statement did not actually help me figure this out, but the fact of the matter is, it is actually, this statement right here is actually being assessed, and it does end up setting this back to true. So I will go ahead and save this, and yeah, we can basically just spin over and over and over again. So this is functioning really nicely. I guess the issue with this bottom part right here is that we basically have a background, and then this is transparent, right? So these sprites are basically going over a transparent background. I don't know if that's like a Pygame bug or what, but yeah, it's not looking great for the time being, but we'll fix that. Alright, so at this point in time, what I would like to do is start keeping track of the actual results of our spin, right? So what I mean by that is that I mentioned over here in our settings that we basically have this game indices of 1, 2, and 3, right? So that is 1, 2, and 3. And of course we have this invisible 0 here, and then this semi-visible 5, which will soon be covered up down here. But basically this is row 1, row 2, and row 3. So what I would like to do is keep track of basically all of the symbols that occur on row 1. Now the issue right now is that I'm keeping track of everything by real, right? So these are vertical, whereas now I want to start to think horizontally. And I could probably do this maintaining the verticality here, but it would be a little bit more difficult for me to like debug and troubleshoot and all that. So what I'm going to do is actually try and output the symbols in row format, and then basically look for the occurrence of 3 or more of them, right? And that will basically determine what the payout is going to be. So this one actually would be a win. So just to set the expectation, right, this is not going to have any crazy advanced payouts. There are some, right, that might consider the diagonal 3 in a row like this to be a win. But for now, I'm just going to do basically a 1, 2, 3 in a row, 4 in a row, or 5 in a row. But I'm also going to keep in mind if we have 3 in a row here and like 3 in a row here, then those will actually stack. So it'll at least be somewhat interesting because that actually does happen quite a bit. I could probably trigger that, you know, just by spinning this a bunch of different times. What I'm going to do is go back to my real.py. Underneath start spin, I'm going to create a new function, and that's going to be called real spin result. And the parameter is just going to be self. And basically what I'm going to do is get and return text representation of symbols in a given real. So that's just going to be spin symbols, and that's currently going to be a blank list. And what I'm going to do is for I in game indices, spin symbols dot append self dot symbol underscore list dot sprites, And we're going to do that at the current index. And then we're going to get the sim type. And then I'm just going to return this backwards. And we'll talk about that in a moment. But basically, what I'm going to do is call this with a function in machine.py. So we're going to have a couple of different functions that relate to determining whether or not there's a winner, and then we're going to have one for win animation and stuff like that. So just bear with me. This is going to get a little bit messy, but it does work, and it will probably, hopefully, make sense in the end. At this point, maintaining order is kind of a fool's game, but yeah, I'm just going to do basically under toggle spinning. Why not? And I'm going to have a get result function. And that's just going to have self. And then I will do a for real in self.real_list. And then we're going to basically iterate through all of our reals and call that real spin result function that I just created. So self.spin result real is going to equal self.real_list real.real spin result. And then I'm going to return this self.spin result. And then I'm actually going to use this output, right, which is going to be a dictionary. And I'm going to actually have a helper function that will flip this horizontally. So for right now, basically what I'm going to do is I'm going to end up getting, and I can probably print this out just to give you an idea. Let's see. I can put that in the cooldowns, I think. When I do this here, I can probably just print get result. And of course that needs to be self. So let's just see what that ends up being. I forgot the -1 here. And this needs to actually be initialized first. So I'm going to create two dictionaries. One is going to be the spin result, and one is going to be the previous result. So we're going to keep track of that here. And I will basically just copy and paste this in since it's a bit difficult to type. All right, cool. So I'm going to spin this until we get a win. All right, so we do have a win here, and it's this hourglass that we see 3 in a row, right? Now the problem is, of course, that win is technically this. And so I'm basically printing out the columns, right, from index 1, game index 1, 2, 3, 1, 2, 3, 1, 2, 3, etc. So I would need to basically compare and look at, you know, look to see matches on the same index, which again I could do, but I think for me and like debugging and stuff like that, it's going to be easier to actually flip this horizontally, right? So I actually have a list that's basically going to be, and this right here would be the bottom one, right? This would be game index 3, but it's telephone 7, hourglass, 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 right? So these are basically across 5 different lists. They're all in the same index, but if I flip them 90 degrees, quote unquote, then I should be able to see them kind of in a row by row format. So I'm going to create a basically a helper file. I'm just going to call that wins.py. Now I'm going to create a couple of different functions in here. In the first, actually the first thing I'm going to do is have a helper functions to detect wins comment. And then I'm going to have my flip horizontal function. And this is basically just going to flip results horizontally to keep them in a more readable list. And then I'm going to have a list called horizontal values for value and result.values horizontal_values.append value. And so this result right here is going to be, it's basically going to be what you see here, right? So what I'm going to do, rotate 90 degrees to get text representation of spin in order. So that's just going to be rows, columns equals length, horizontal values, and then the length of horizontal values at index 0. And then I'm going to have a list called hvals2, and this is just going to create our list of lists. And then I'll do another for loop for x in range rows and a nested for loop for y in range calls. And then my hvals2 y index will be rows minus x minus 1. And that's just going to be my horizontal values at index x, y. So then hvals3 equals item, and we're going to reverse this. Item and then reverse for item in hvals2. And I need to get rid of the p here. And finally, we'll just return hvals3. So you'll see what this does here in just a second. So in my machine.py, in order to use what's in wins.py, I will need to, from wins, import star. And finally, what I can do is that print statement that I had right here, get result can actually be fed into flip horizontal. Of course, this needs self. So this is now a row of 5. Starting with floppy, telephone, 7, diamond, and diamond. And that looks right. And then the next one will be another row of 5, or our index 2, game index 2, diamond, hourglass, telephone, floppy, diamond. And then finally, we'll have the hourglass, floppy, 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 7. So if you can see where I'm going with this, now it's a little bit easier for me to just look. I can basically iterate through my list and then look for the same symbol repeating at least 3 times. And if it is, then I'll basically call that a hit, right? So I'm going to go back to my wins.py file. I'm going to close this really quickly. And I'm going to create a new function. And that is going to be called longest sequence, or seek for short. And then I will just have hit be the basically the only parameter there, and that's just going to be sub seek length and longest are both equal to 1 and 1. And then what I'm going to do is have a start and an end index of 0, 0, and then I'm going to do a for loop for I in range len hit, which again is going to be my input. And then I'm going to subtract 1 to that, so we can adhere to indices starting with 0. Then I'm going to have an if statement. If hit at index I is equal to hit next index, which is just I plus 1, minus 1, then I will increment my sub seek length by 1. Then what I'll do is check the length of subseek length. So if subseek length is greater than longest, then I'm going to make longest equal to subseek length. And then I'm also going to change my start to I plus 2 minus subseek length. And finally, my end will be equal to I plus 2. And then I'm going to go back to this if statement and have an else. And basically, I'll just set my subsequence length back to 1. So basically what's happening here is I'm keeping track of, and I'll go ahead and run this again so you can see it, is I'm going to basically go through, and I'm going to have basically a list of hits. And a hit is going to be a row that has a count of a particular symbol 3 times or more. So there would be no hits here, and thus in my logic I would never call longest sequence, right? But if I go ahead and spin this, eventually I will have 3 of the same symbol in one row, in theory. There we go. Okay, so we would have a hit here. Now what I would go through is basically say, okay, do I have a subsequence? And so when I get to a particular symbol, then I basically have my subsequence. If I get to the same symbol after it, then I will increment subsequence. Now if this was not a floppy, then this would trigger, and it would set my subsequence back to a length of 1. Right, but it is, so it ends up being 3. And if I end up having a length of 3, then this will actually pay out. So we're going to go ahead and work on that logic here in a second. And that is going to lead us to a new function. And so we're going to put that under get result, since this is along the same lines. And then it's going to be called def check wins. And that's going to take self and result as a parameter. So my hits is just going to be a dictionary. I said it was a list. It's actually a dictionary. And what I'm going to do is start by getting my horizontal, which again is the flip horizontal result. And this basically goes back to right here. So we're basically inputting this into our check wins function. And I can actually just delete this for now. We'll go back down to check wins. And what I'm going to do is iterate through the rows, and for row in horizontal. And then I'm going to iterate through the symbols for sim in row. If row.count symbol is greater than 2, that means that we see the same symbol more than twice, we're going to have a potential win. Now we haven't determined if they're all connected yet, right? But what I'm going to do then is I'm going to create a new variable called possible win. And that's going to be index for index value in enumerate row if the symbol is equal to the value. So this right here will actually result in a list of indices, right? Basically, we're going to have that stored as possible win. And then what I'm going to do is check possible win for a subsequence longer than 2 and add to hits. Okay. So then what we're going to do is if len longest sequence possible win is greater than 2, we're going to add hits horizontal.index row +1, right? So we can adhere to 0 index. And we're just going to set that to a list, which is sim, and then the longest sequence possible win. So, going back to the longest sequence, finally we need a return statement. And that's just going to return hit at our start index and our end index. So in this case, our start index is going to be 0. Our end index is going to be 1, 2. So this is going to return the hit 0, 1, 2. Now the last thing we're going to do with check wins is if hits, meaning if there are actual hits or there is a win, we're just going to return hits. So we do need to add something in our cooldowns. And basically what I'm going to do is every time we toggle this back to being able to spin, right? That basically means our spin is done. So as part of our cooldown, we also need to basically check to see if there is a win, right? So if self.check_wins self.spin result, then we're going to play the win sound. Save this as self.win_data. And then again, that is check wins self.spin result. I'm going to put this at the top. And I'm going to have my sounds here. Self.play when sound, self.win underscore data. So I'm going to have a function called play when sound. We'll talk about that in a bit. But I'm also going to have self.pay underscore player, self.win data, and self.cur player. So we don't have our player yet. That is coming shortly. We're also going to have a self.win underscore animation ongoing set to true, which we currently have not initialized, but I'm going to do that up here. And we'll just have that set to false at first. And this will basically help us with our win animation here in a bit. But beyond that, I'm actually going to do something. I'm going to update our UI as well. So we don't have a UI at this point, but I'm going to have a self.ui.win text angle equals random.randint -4 and 4. So this is basically going to give the player a message that says how much they won, and it's going to change the angle that it is displayed to the player, just so it's not like the same message every single time someone gets a win. Okay, so I'm just going to comment these out for now since we don't have any logic for them. And I think at this point we can go ahead and work on our player class. So the player is going to be its own file, of course, and I'm just going to call that player.py and save this. And finally, we're going to have a from settings import star, and that's the only import that we actually need. So then I'm going to create my class player, and of course we need to define our init function with self as the parameter. And so now I'm going to set all of the balances and bet sizes and stuff like that about the player, right? And that is just going to occur once when we create the player. So that's just going to be a self.balance equals 1000, a self.bet size equals 10, self.last payout will be equal to 0, self.total 1 will be equal to 0, and self.total wager will be equal to 0. So we're going to have a couple of functions. We're going to have a get data function, which basically is just going to pull all of this data, and that's going to help us create our user interface. And then we're also going to have a place bet function, which basically will just, grab my bet size and then remove it from my balance, and then add that to the total wager. So that's a super easy function. But yeah, we're going to start with our def get data, and then we're going to have player data equal to just a blank dictionary at first. And so that's just going to have, we're basically going to have balance, bet size, last payout, total won, and total wagered, but we're going to have them formatted as if they were like a dollar amount, right? So it's going to have the same .00 every single time, and we just want to make sure that that displays nicely. I'm actually just going to copy and paste this. So yeah, there we go. The formatting right here is just this, the decimal. Basically, we'll always have 2 decimal places, and then we'll just return to that dictionary as player data. And then finally, we'll have the super easy place bet function that just takes self. And then finally, bet is going to be equal to bet size, self.bet size. And then we're going to have self.balance minus equals the bet. So we're going to subtract that from balance. And then we're going to have a self.total wager plus equals our bet, right? So we'll keep track of that. So now I can go back to machine. And back when I spawn my reels, it also makes sense to create a player. So I'm going to set self.curPlayer equal to my player class, which of course means that I need to import it. And I can do that with the from player import player line here. So recall that we had this self.payPlayer commented out, right? Now we can actually pay the player. But what I want to do is basically every time that this happens, I need to get my player data. So I can just print cur player, And again, this needs to be self.cur_player.get data, right? And I should be able to close this and rerun this. I'm going to clear it. Okay, so we have a none type, has no length. So why is that? I think let's see. And I noticed that I actually need to get my result up here. So I'm going to have self spin result equal to self.get_result. All right, let's give that a try. So machine has no attribute pay player. Yep, that is right. I have not created that just yet. And that's just going to take self, win data, and the current player as parameters. So we're going to try and make this a little bit more interesting. My multiplier is going to be based on the number of symbols that are in a row, right? So if there's 3 in a row, it'll be 3, 4 in a row, 4, 5 in a row, 5, right? It's kind of boring, but it works. So what I'm going to do is multiplier equals 0, and then my spin payout will also be equal to 0. So what I'm going to do is a for v and win data dot values. And then I'm going to basically just say my multiplier plus equals the length of whatever the value is, right? So that should just be the length of v. So then I can do a spin payout equals multiplier times the cur player dot bet size, and this will grab their current bet size, which again we set to $10. And now what I'll do is set the current player's balance, which will basically just increment that by the spin payout, right? And then I'm going to subtract the spin payout from the machine balance, self.machine balance minus equals spin payout. And I haven't set the machine balance yet, so I need to do that. But then I'll also self.cur_player.last payout will be whatever the spin payout is. So the machine balance, think of that as if you deployed your own slot machine in like a restaurant or a casino or something like that. Like, it has to pay money for the times that, you know, someone wins, right? You can't just put the slot machine out there and expect that, you know, it's never going to pay anything out, right? Especially this slot machine, for example. Like, if someone just walked up to it and they won on the first time, there'd have to be money to pay out, right? So basically, I need my machine to have a starting balance itself. And I'm basically just going to set that to a super arbitrary $10,000. Self.machine balance equals $10,000. And now this should work. Okay, so that was not a win. No wins yet. Okay, so this is a win. And what we have is we see a balance of $1,020, which is interesting. It should probably be less. Let's see, bet size $10, last payout $20. Okay, so something's wrong. So we can go back up to our input. So I need to actually have the current player place a bet. And then I also need to have the self.machine balance increment of the bet size, and then set this last payout to none. So I just had those commented out when I was writing this a bit earlier. Let's go ahead and try that again. I'm going to print the player data here. Print self.cur_player.getData. Okay, and then I'm going to get rid of this print statement. And we'll try that again. Okay, so it prints twice, which is a bit annoying. Oh, you see that? So we need to take a look at our cooldowns because obviously if I just hold the space bar, it's just printing that over and over and over again. So this goes back to our check, and I need to make sure that I can actually toggle, in this case, spin, right? So let's go ahead and try that again. Okay, so now it's only printing one line at a time. I'm actually holding the space bar down, but it's only letting me when everything has stopped spinning. Cool. So I'm actually going to pay attention to this a little bit more. I'm going to clear that, run this. Okay, so right now my first wager should happen as soon as I hit spacebar. And we see that my balance is lower by my bet size, so it's 990. My last payout is NA because I haven't gotten paid. My total won is 0 because I haven't won anything, and my total wager is $10. And this is not updating if I get a win. It's only updating like as I press the button, right? So this is not the best way of doing it. But at least we see it removing my bet from the balance each time, which is... Okay, so here is a win, right? So the last balance was 920. My total wager was 100. Okay, so something still isn't working right with my last payout and total 1, so let's take a look at that. So I actually forgot. I need to have index 1 here for my multiplier. Okay, so we have a win. I'm actually printing my win data now. So my total 1, the next time I should spend this, should be $30. And I also need to have a total 1 here. Cur player dot total 1 is going to be equal to spin plus equal spin payout. Alright, so now I should be able to try this again. Okay, so with a balance of 970 and then a win, my balance should be $1,000. We should see a last payout of 30, a total 1, 30, and total wager should go to 40. So we actually see balance 990 because I have done another $10 bet, but it looks like everything is updating as it should. Last payout goes back to 0 because we didn't win last time. Total 1 stays at 30. Stays at 30. Total wager keeps going up by 10, which is the bet size. Okay, so this is interesting. This should be a 6x multiple of our bet, right? Because we got 2 sets of 3. So, accounting for the balance of the $10 bet, so that would go to 970, but we have a trailing win of 60. So 970 plus 60 should be 1,030 should be the balance, and then the total 1 should increase as well. So as you can see, it's kind of difficult to test this, and we were like adding print statements and stuff constantly, so it kind of makes sense to go back and think about actually having a debugger. So I'm essentially using the same debugger logic that you would find in the clear code videos. But yeah, I'm going to go ahead and create a new file called debug.py. Save that as debug.py, and then basically just import Pygame. Okay, and this is taken right out of the clear code playbook. So thank you, clear code. But yeah, so what I can do at this point is basically go back to my machine.py and then go back down to my update, right? So within update, I can basically create my debugger down here, and I'll say balance payout debugger. And what I'm going to have is my debug player data is going to be set to my self.curPlayer.get data. And then I'm going to have my machine balance equal to and this goes back to that pretty ugly formatting here, to f dot format self dot machine balance, right? Then I'm going to have basically an if statement. If self dot cur player dot last payout, that means if they had a payout last spin, then I will set that to, our last payout will be set to whatever that was within the current player object, and I'll just paste this in. And then in my else statement, I'll just set last payout to NA. And finally, I'll pass that into the debug function, and that will just be an F string. And of course, I need to import debug. So from debug, import debug. And finally, I can run this. And so we can see in the top left, basically what the player balance is, the machine balance is, and the last payout, right? So if I start spinning, then we can basically keep track of what's going on. So the machine gained $10, and I lost $10 because I bet and did not win. Now, if we keep going, and we'll start to notice that like there aren't a super frequent amount of wins. This is a win, though. Okay, so we subtracted 30 from the machine balance. And my last payout is now added to my player balance, which brings me back up to 990. And this will work pretty nicely. The issue is it's hard to like get a 4 or 5 symbol match, right? Because it's statistically rare with the number of symbols that we have in our reels and the fact that we're doing random. So I can actually increase the odds of that. And in order to increase the odds, I will go over to my settings file, and we'll just remove, so what do I have here? I have 5 symbols. I'll just get rid of the, let's see, I'll get rid of the 7, and I will just have a second hourglass. 4 symbols, 4 more wins. Okay. So I'll paste that in, and I will change this to hourglass 2, and then I'll just load this twice. So that should be quite a bit more likely to get a win. And let's see if that's true. Okay, so there you have 4 of these in a row. Now, I got a bizarre number for my total one. And I don't know why that said 110. Okay, so we need to find another example. So the issue is that these should not actually be indented. So that was quite the rabbit hole. But I think everything should be paying the right way now. And we should see total one is 60 and last payout is 60. And there we go. So with the proper indentation, it looks like our pay logic is actually working as intended. And to do the math just really quickly, my balance minus all that I've wagered, starting from 1,000 would be 960, but I've won 60, which means my balance is 1,020. So I've committed the changes to the repo, as you can see here, and what I'm going to do is actually start with the user interface. So in order to get rid of the, I guess the icons that were, or the symbols rather, that are kind of bleeding in that bottom like 100 pixels that I mentioned, we're going to go ahead and draw a bar there, and that's actually going to be the basis of our user interface. So in going back to the code, I'm going to create a new file, and that actually is just going to be ui.py. And I'm going to need a couple of imports here. So I'm going to need the player from player import player, and then I'm going to need from settings import everything, and finally import Pygame and random. So then I'm going to create my UI class, which will have a pretty boring name and just be UI. And then I'm going to have my init method, or function rather, def init, and that is going to take self and the player. So we're going to get a bunch of info from the player, and that's actually going to be displayed as part of the user interface, like the balance and the bet size and stuff like that. So I'm going to go ahead and get the display surface by calling, or by creating a new self.display surface variable within init, and that's just going to be pygame.display.getSurface. And then I'm going to have basically I'm going to have two different fonts, and I did this because I was experiencing issues with basically drawing the fonts in different places. I don't know if you need to have multiple occurrences of the same font, but in any case, I did. So I'm going to call the two variables self.font and self.betFont, and those are going to be equal to pygame.font.font, UI font, and UI font size. And then the second instance of that will actually be identical, so I'm just going to copy and paste. And this is yelling at me because I don't actually have UI font or UI font size in settings yet. So I will go over to settings, and what I'm going to do within settings is actually add a new section, and that's going to be text. So here I'm going to have text color, and that's just going to be white, and I'm going to have my UI font equal to graphics font kidspace.ttf, and this is just a font that I thought matched the aesthetic of the icons / symbols that I decided to use. Unfortunately, since I got this from Dafont, I cannot distribute it, but you can simply find this on Dafont by searching for it. And then what I'm going to do is set the UI font size to 30. And finally, I'm going to have a win font size, which is going to be 110. So back over in UI, these will no longer throw errors, which is good. And then I can go ahead and continue on. So afterwards, I am going to create a win font, which will be self.win font equal to pygame.font.font, UI font, and then win font size. And I basically had the win text angle, which I discussed briefly earlier, but we need to have that in the init function as well. So the first time that this, so basically when the UI is created, there is that variable. So I'm going to just have a self.win text angle and set that to a random.randint. And the settings that I used before were -4 and 4. So we also need a function to display the info, and that is just going to be display info. Self will be the only parameter there. And so I'm going to get the player data using the player, or rather so I'm going to get the player data using the get data function available to player. So player data is going to be equal to self.player.get data. And then what I want to do is get the balance and bet size. And I will go ahead and do a balance surface and set that equal to, and of course this is the text that's associated with that. So self.font.render. And this is going to be kind of an elaborate string here, or rather set of parameters here. So I'm just going to paste that in, but I'll walk through it. So this is going to print basically a balance, and then it's going to have the $sign, and then grab the balance from player data, which again is a dictionary. And then these settings here, I can't remember exactly what they are off the top of my head, but they are in the documentation for font. In any case, I will go ahead and create my coordinates. So x and y are going to be equal to 20, and then I'm basically going to get the y value of my display surface and then subtract 30 pixels from it. So this basically means it's going to be 30 pixels above the very bottom of the screen. So self.display_surface.getSize. And then get size returns a tuple of an x and y value. So I'm going to get the y value there and subtract 30 from it as mentioned. And then I'm going to create a rectangle for the balance surface, and that's going to be balance rect, and set that equal to balance surf dot get rect. And then our bottom left is going to be our x and our y value defined above. So I also need one to display the bet, and this is basically going to look identical to the above, but we're going to place that in a different location. But bet surface is going to be equal to self.bet_font.render, and then I'm going to paste in my parameters again. And as you can see here, I'm just going to have wager, and then it's going to grab the bet size from player data there. But then we're going to create a new x value. The y value can stay the same, but my x value will change, and that's going to be self.display_surface.getSize. And now we're going to get the x value, which is the 0 index, and then I'm going to subtract 20 from that, so it's a bit off of the edge. And then I'm going to basically have the rectangle, bet rectangle, is going to be set to bet surf.getRect, and set the bottom right equal to our new x value and our old y value. So then I'm going to actually draw these, and that's just going to be pygame.draw.rect and self-display surface. And I can't remember exactly what the false is, but again, if you're interested in what that is, it's in the draw.rect documentation. But then the third parameter there is going to be the rectangle itself. And lastly, or not lastly, but next, pygame.draw.rect for the bet rectangle. And that's going to be self.display surface and false again, and bet rect. And then I need to actually blit these on the display surface. So self.display_surface.blit, balance surf, and balance rect. And the same thing for the bet, self.display_surface.blit, bet surf, and bet rect. And then if there's a win, we're going to display that. So for the last spin, if there is basically a last payout within our player data, then that will basically be what they won previously, right? So we do want to display that in the UI. And I will just have a note, or a comment rather, that says print last win if applicable. And then I can just check to see if that self.player.lastPayout exists. So if self.player.lastPayout, then I'm going to grab that from my player data. So last payout will be equal to player data last payout. And then I will have my win surface be self.win_font.render, and I will input my parameters. And then I will create a new x value of 800, which is basically the midpoint of my screen, and then I'll have a y value of I guess 60 pixels above the bottom of the screen. So self.display_surface.getSize, and then again the y value is the 1 index minus 60. So then I'm actually going to call pygame.transform.rotate on my win surface, and that is going to basically tilt the text. So all the text is not, identically spaced / angled / whatever. It's kind of boring. So you'll see that in a moment. But I'll basically do that on the windsurf, and then the angle, which will be self.winTextAngle. And this needs to be surf. And then my rectangle will be based on that newly modified surface. So when surf.getRect in the center will be equal to my x1, y1 values. And then I'll blit that with self.display surface.blit when surf and when rect. So finally, I do need an update function for my UI, and that's just going to be def update self, and this will be fairly simple. I will just have a pygame.draw.rectangle, and this is where we're going to get rid of the screen bleeding that we've been seeing before. I am just going to paste in the parameters because they are fairly lengthy. So we're basically taking the display surface, we're making a black bar, and then that is going to be a rectangle, and these are the coordinates for that. And then I'll just self.display_info. And so I need to constantly update the UI, and I'll actually do that in the machine update class. And I'm going to get rid of the debugger. I don't think that we need it anymore. Knock on wood. And I'll basically just leave this here commented out. And finally, I will just add my self.ui.update. But you'll notice that there is no import for the UI yet, so I'll go all the way up to the top, and I will find the right spot for that. From UI, import UI. And then I need to actually create a UI in my init function. So similar to the cur player, I will just create self.ui and set that equal to the UI class self.curPlayer, since it does take a player as an input parameter for the init function. And there is one very important piece of this puzzle that I forgot, and that is to have self.player equal to our player parameter. So now we should be able to actually run this. And you see that we have our starting balance. This actually looks way nicer without that screen bleed there. So this black bar at the bottom is actually covering up those symbols that we were seeing before, and this looks significantly better. And as you can see, we have a win here, and that ends up showing up in the UI. And so you can't really tell here, but it is angled a little bit. Again, that is a random angle. So there is a chance that it isn't angled at all, right? But typically, yeah, this one you can tell a little bit more. Typically, this will show up as being angled. And I'm just going to run through this and make sure that everything's looking right. This is a 3, and this is a 4, so the win is, in fact, 70. Let's see if the balance is updating right as well. So yeah, we just had 1080 and that updated to 1110. So we're still printing out all this data here. I'm going to get rid of that since everything is looking pretty nice at this point. I'll go ahead and clear this, and we will go back over to the machine where all those print statements are. And those were in check wins, I believe it was. No, they were in pay player. So we're printing the win data. I don't need to do that anymore. And then I'll just control F for print. And I'm doing that here as well. And I think that's it. So if I go ahead and rerun this, it should be a bit cleaner. No print statements. And I am still showing the wins properly. So this is going to be a lot cooler when we have sounds and stuff like that. But again, you know, in keeping with the whole I can't distribute the sounds that I used spiel that I've been going on and on about, I'm just going to keep those commented, I think, for the remainder until I'm able to demo the full thing at the very end when I swap in the icons. Now, one thing that I wanted to mention is that this grid right here is actually being drawn underneath the symbols. So when they rotate, and it's kind of hard to tell, but they're going above the grid, right? And there might be, I don't know, like some people might think that that's okay. Me personally, I think it would be cool if there was this effect where if they were underneath the grid. So I actually have a grid that we can add to this, and we'll basically do that in the main.py function. But if I close this and I go back over to main, we can kind of see why that is, right? So we're updating the machine, and we have our background image right here. So this is what basically is responsible for any animation or whatever. This is where that is occurring. So if I were to draw something after that, basically another background image, then that would appear to be on top of everything that's going on here, right? So what I can do is actually create basically a new image, and I can do that right here. And I'll just say self.grid image, and I'll set that to pygame.image.load. And I will probably just want to add that in settings, I would imagine. And I'll have grid image path and set that to graphics 0. And then I need to make sure that I have the right file name for that. And I will go back over to main.py. And actually, I need to make sure that I copy this. So in main.py, I will have that in my image.load, and then basically I'll just blit that here. Self.screen.blit, self.grid image, and then I want that to be in the same place as the background image. And now, if I run that, and I'll actually want to convert both of these. So I'll go ahead and copy and paste that. And so it's hard to tell, but this actually does occur underneath. And let me make this a bit more obvious, right? And I think I can do that by changing this. I'm going to change this to the higher opacity grid line and try that again. Okay, so this one is a bit more obvious, and it kind of has a little glow to it, and I think it looks pretty nice. Again, you might not want the grid lines at all. You might think that it just looks better without them. But I think for the purpose of this, I'm going to leave them on just so you can kind of get the idea of that layered image that we have right here, right? We have the background, and then we have all the animations and stuff like that, and then we have the grid on top of it, which kind of gives it this layered look. So basically, there's one problem, and that is that this looks a bit boring when you actually get a win. It would be kind of cool to like highlight the, I guess, the symbols that were part of your win, right? Or, just make them more obvious. So if I actually get a win, for the instance right here, wouldn't it be nice if you could just like make them, I don't know, do something, animate them, whatever. So I have basically gone through the process of figuring out a way to visually differentiate the winning symbols from the non-winning symbols. And that involves making these move slightly by increasing the size of the rectangle, and then making the ones that were not winning symbols fade out a little bit. And it actually gives it a really nice kind of visual look. And I'm going to actually do that in a new function. That function is going to be called win animation, and I'm going to do that within the machine class. And that's going to be pretty much down here at the bottom. Again, it doesn't really matter, but def win animation, and it does not take anything other than self as a parameter. So this one is somewhat lengthy, but what I'm going to do is check to see if my win animation is ongoing, and that is just a boolean, and I believe we have win animation ongoing. So that is currently set to false, and I don't think we changed that yet. So we'll have to go ahead and set that to true at some point. But for right now, we're just going to say if self.win animation ongoing and self.win data. So this is basically going to check to see if there is win data, right? Because if there isn't, then that means that there was not a win. Then what we're going to do is we're going to say for key value in list self.win-data.items. We're going to get if k equals 1. And basically what this is doing is determining which row the symbol that won is on, and thus which row should have an animation. So this is kind of going back to the way where we we've inversed our indices several times. This is yet another kind of way of doing that. Again, not super ideal, but it works, and it's kind of easier to debug visually, at least for me. So if k is 1, my animation row is going to be 3. And elif k equals 3, my animation row is going to be 1. And else animation row is just going to be 2. So basically this is just flipping 1 and 3, right? And then 2 is always in the middle, so it will just stay the same. But yeah, so then I'm going to have my animation columns, and I'm going to have that set to my, basically the indices that I get within my value at index 1 within WinData. And I believe in my README I actually discuss what WinData looks like, because it does come up quite a bit. So I'm going to actually put that in this README here because I don't think it's there yet. And I'll just add that here. So WinData is formatted as such. This is a key, and this is the value. So V1 is this, which is basically a list of indices where you see Clover. So hopefully that makes sense. But I'm going to go back to machine and basically say my animation columns is equal to that V1. So after that, I'm basically going to iterate through my real list. So for real in self.real list, if real in animation columns, and so I'm going to check to see if the real is in my animation columns, and then I'm also going to check a boolean, which is going to be called canAnimate, self.canAnimate. And so this actually isn't set yet, and I need to set that in my init function. And I will set that up here next to this when animation ongoing. So self.canAnimate will be false to start. So now that I have set this in my init function, I am going to go ahead and do a self.real list at index real. And then I'm going to grab the symbol list and then the sprite list. And this is actually available to the Sprite Group within Python, or Pygame rather. And then I'm just going to the index of animation row, and I'm going to set a boolean called fade in to true. So I will need to actually go into my symbol class and make sure that I have this boolean present. I don't think that it is right now, but we'll get to that in just a second. And I'm going to have a nested for loop for symbol in self.realList at index real dot symbol list. If not symbol dot fade in, which basically means if we did not set fade in to true, which is only going to happen if this is not true, right? It's just going to continue to be false. So if that is still false, basically is what we're saying, symbol.fadeOut is going to be set to true. So we also need to have a fade out available within our symbol class. And so that basically means that I need to go back over to my real. It's been a while since we have been in real. But basically I need to go down to symbol. And within symbol, we're going to create a new little section here, and I'm going to have a comment called used for when animations. So there are a couple things that I want here. I do want an X and Y value available to me. And I'm going to have a self.size X equal to 300 at first, and a self.size Y also 300. And this is just the dimensions of my symbols, right? 300 by 300. Then I'm going to have an alpha value, self.alpha, and that's going to be equal to the maximum alpha value of 255. And then I'm going to have my two booleans, self.fadeOut, and that will be false, and self.fadeIn, and that will also be false. So what I can do at this point is basically look at the update class, which right now is doing nothing. But what I need to do is update them when fade out or fade in are not false. So what I'll do is set a comment here. Slightly increases size of winning symbols. If self.fadeIn, and then if self.size of x is less than 320, self.size x is going to be plus equal 1, and self.size y is also going to be plus equal 1. And then we're going to do a self.image equal to pygame.transform.scale self.image, and then we're going to have our two coordinates self.size x and self.size y. So basically this transform.scale is literally going to take our input image and then increase it to the size that we say. So the first time this runs, because self.size will be less than 320 when it's at 300, we're just going to add 1, right? And then we're going to transform that image by taking said image and turning it into a 301 by 301 version of itself. And it's going to do that until basically the last time it'll do that is when it's 319 by 319. And then the animation will be over. So we also need to have one for fades out non-winning symbols. And that's just going to be an elif not self.fadeIn and self.fadeOut if self.alpha is greater than 115, which it will be because we're going to set it to 255 in the beginning. We're just going to self.alpha minus equals 7, and then self.image.set alpha self alpha, right? So the first time this runs, we're going to have an alpha of 255, which is greater than 115, which means we're going to subtract 7 from 255, and then we're going to update the image. And this will happen multiple times until self.alpha is no longer greater than 115, and the animation will be over. So back in machine.py, there are a couple things that we need to do. First of all, we need to constantly check to see if there's a win animation going on. So I'll just add this under the UI update, self.win animation. And then we also need to have a place where we set our win animation ongoing, right? And so when we go up to toggle spinning, there is this for loop here, which is where we basically kind of start the spinning animation. And what I also need to do, and I'm going to do this after I play the sound, is I'm going to self.win animation ongoing. And I'm going to set that to false again here, because even if we just did a win animation, I know that since this is essentially when we start spinning, that needs to be false again, so we're no longer doing that animation. But as we can see down here in check wins, basically we have this case where there are in fact wins, right? And that's if this hits exists. So at this point, what I'm going to do is self.can animate, and I'm going to set that to true. So basically what that will do is allow this to end up being true, right? But we still have not set this to true. So in order to do that, I will go back up to Cooldowns, and we have a place that we've actually commented this out already. So if I get rid of that comment there, I can also get rid of the comment here. And now I should actually have cases where, so if self check wins, and basically that means if this is not empty, then get win data. So I get win data, which basically means there is that existence of hits, right? And if there is an existence of hits, then the win animation should actually be set to true. So in order to test that, there we go. So it's nothing crazy, but basically it does make these move slightly, and then it fades out the non-winning symbols. And it even works when we have 4. Let's see if we can get a case where we have like 2 sets of 3. There's 1 set of 3, 1 set of 3, And there we go. So this is actually a win that has two sections where the animation takes place. And this is not the craziest win animation by any means, but it does give you kind of a visual cue of where the win took place. So the very last thing that I wanted to talk about is how I can play different sounds based on how many symbols actually hit, right? And so all the way back up in my machine, in the init function, I'm just going to create basically a new little section here, import sounds, and we'll just have, yeah, I think that's good for now. And what I will do, I'm going to copy and paste this in because it is quite a bit of basically the same text over and over. So within this section here, I have 3 different win sounds, and I'm basically going to choose which one to play based on how many number of symbols I have in my win, right? So this one will actually be a little bit higher pitched, and it will sound like, oh, you know, this is actually more emphasized than, say, 4, which is more emphasized than, say, 3. So it will be kind of a nice audio cue to the player when they get a larger win. And in order to kind of determine that logic, we have this right here, right, which does a call to a function called play win sound, which I have not created yet. It is relatively simple, and I'm going to go ahead and put that right above the win animation that I just created. So I'll have a def play win sound, and that is going to take in win data as a parameter. And so I'm going to have a sum variable set to 0 for item in win data.values. Sum plus equals the length of that list that we always get, right? Item 1. And of course, it's going back to the README. So the sum of this is what we're going to, or the length of this is what we're going to add to our sum. So in the case of a 3 symbol win, sum will now be equal to 3. But I could have multiple lines, right? If I do have multiple lines, then I would just want to add that up. So if I have a 3 and a 4, then this will end up being 7, right? So what I'd like to do here is basically check if sum is equal to 3, self.win3.play. Conversely, elif sum equals 4, self.win4.play. And lastly, elif sum greater than 4, self.win5.play. And so basically this will play a different sound based on the number of symbols that are technically winning symbols. And again, it just kind of gives a nice little audio cue to the player. And I will demonstrate that here in a moment. And finally, I'll just uncomment the self.spin sound play, and so we'll actually have a real sound. So that was pretty much it, but there was no real stopping spinning sound, which I would like to have, and I think that should go in the real class. And so recall that we had a real is stopping. So if we actually have real is stopping set to true, and real is spinning set to false, then I'll go ahead and have my stop sound play. And I do not believe I've actually imported that because this is commented out. So I will get rid of that comment, and we should be good to go. So at this point, I'm going to go through and I am going to save everything. This is by and large the end of the tutorial. And so what I'd like to do is basically show you how easy it is to change out the symbols. And I will go ahead and basically run the slot machine a whole bunch of times using my symbols and the main music just to kind of send this thing home one final time. But what I have is basically a new symbols dictionary. So when I go back to settings.py, this is where I'm going to change things, right? And so in my settings.py, I basically have some symbols that I have licensed out elsewhere as mentioned. And what I would like to do is just copy those in. I'm going to comment these out for now, and then I'm going to copy in my symbols, which will just be basically a different symbol path, and I will have to add those in. So I can simply change the sim path to reflect that, right? Sim path equals graphics neon symbols. And in my case, I actually want this to be different as well, and I'm going to get rid of the grid. So that means I need to go back to main.py and comment this out, as well as this. But that should be enough to switch the symbols. So I'm going to go ahead and tidy things up a bit, and then I'm going to push all of the source to the repo here. I might make some slight changes, but by and large, everything we've done in the tutorial up until this point should be present in the code that you see here. So the one thing that I did want to touch on again is that if you're going to make changes to graphics, it makes sense to kind of do that in the graphics directory, as well as audio in the audio directory. And it should be pretty easy, like I said, to swap out the symbols for some new, nicer ones, as well as the audio. And yeah, hopefully you have fun with this, and hopefully it was informative, especially if you spent the entire time working through this with me. I know it was probably several hours by the time I finished editing this, but I wanted to thank you for watching, and see you in the next one.